Okay? Still on differentiation, but we are looking at implicit function. Now, in implicit function is talking about when you have x and y together on the same side. You know, all you want to be doing, y is at this side, then x is at the other side. But when you have x and y together at the same side, maybe you have something like, you know, this one now is explicit function. Explicit means y is on one side, x is on the other side. But if you have something like this, this is implicit function. Why? X and y are together at one side. Okay? Now, having said that, now, if for example, I have x cubed y squared, look at this, and I just want to differentiate something like this. You know, x and y are together. Now, I am going to say that differentiate this x raised to power 3. Of course, it will give me 3x squared. Bring down the 3 and minus 1. You see that? Then the y squared, just put it beside it. You are not touching it yet. Then plus, this time around now, differentiate the y squared. You know, if I differentiate the y squared, it's going to give me 2y. Then this s cubed, don't touch it, just write it beside it. But you know, you can rearrange this. You can write it so that it will be in this form, 2x cubed y. That's a better way of putting it. So it means this one now, but look at what I did. I will first differentiate this and keep this constant. Then differentiate this, which is 2y, and then keep this constant. But because in lettering, in A, B, C, D, x always comes before y. So write the x cubed and then the y. So it means a better way to put this is to say 2x cubed y. So with this now, you have done the differentiation of this question. So now, having said that, let's now look at a typical question. They can say, given x squared plus y squared equals 12, and they say, find the derivative. Now, by saying you should find the derivative, they are asking you to look for the differentiation. So, how do you solve something like this? Solution. So, this one is x squared. So, if you differentiate it, you have 2x. Plus this one is y squared. If you differentiate it, you have 2y. And because you are differentiating with respect to y, you put the y dx beside it. It's a must. Anytime you differentiate anything with y, you always put the y dx by the side. Equals 12. And then the next thing is that this 2x will move it to the other side. So I'm now going to have 2y dy dx equals 12 minus 2x. That is this plus 2x. Bringing it here will change to minus 2x. So for us to get the y dx, you will divide both sides by 2y. So if this 2y cancel this 2y, this dy dx, let me write it here. The y dx, which is what we are looking for, will now be equal to what? 12 minus 2x over what? 2y. That's your final answer. Do you see that? Very straightforward. Pause the video and then copy this. If you don't understand, try to watch the video again for better understanding. Now look at this question again. Let's say you have 4x squared plus 2y cubed plus 3xy equals 12. Find the slope. Don't forget, slope is the same thing as differentiation. It's the same thing as derivative. It's the same thing as dy dx. Now look at this question. You want to solve. Use an example of implicit function. So let's start with this one now. Solution. So I can say, let's differentiate this one. That will be 2 times 4. That is 8x. You know, if you minus 1 from this, you will be left with 1. And there's no need for you to write down 1. Then plus 2y squared. If you differentiate this, 3 times 2, that will be 6y squared. Because 3 minus 1 is squared. But because you differentiated with respect to y, you will put dy dx by the side. You do not put dy dx by the side of this one because it does not have, it's only x. So it is when you differentiate with respect to y that you put dy dx. Then look at this one, plus differentiate 3xy. You know, when you differentiate 3xy with respect to x, your answer will be 3y. Why? You know, if you differentiate 4x, your answer is 4. If you differentiate 8x, your answer is 8. So if you differentiate 3yx, your answer will be 3y. You are just picking what is beside the x. So even though they rearrange this as 3xy, by the time you differentiate with respect to x, you only pick the 3 and the y. That's 3y. And that's why I have 3y here with respect to x. Then if I want to differentiate with respect to y, because you have to do that, why? Because you have x and y together. So you will first do with x, then you will do with y. So if I want to differentiate with respect to y now, my answer will now be 3x dy dx. Don't forget, when you differentiate with respect to y, you must always put dy dx by the side. Then, if you differentiate 12, that will give you 0. So now, all the ones that have dy dx, let them be on one side. And the ones that do not have the y dx, take them to the other side. So, this one has the y dx, so I'm going to have 6y squared dy dx plus 3x dy dx equals, this is 8x, bring it here to change to minus 8x. This is plus 3y, bring it to the other side to change to minus 3y. You see that? This 8x is having invisible plus. By the time it crosses over equal mark, it will change. This plus 3y, by the time it crosses over equal mark, it will also change. So I'll be left with this and this at this side. Why am I keeping these ones at this side? Because they have dy dx. So I'll now say dy dx is common. Bring it out. Dy dx into brackets. So I'll be left with 6y squared plus 3x. You see that? Equals minus 8x minus 3y. Do you see that? So now, I expected you to have written this. Permit me to clean this. So I am now going to say that for us to be able to get my dy dx, I will now divide both sides by 6y squared plus 3x. So I'll say dy dx into bracket 6y squared plus 3x equals minus 8x minus 3y. So divide both sides by 6y squared plus 3x. 6y squared plus 3x. So when you divide that, so your final answer will now be that this will cancel this. The dy dx, bring it down. dy dx will now be equal to write this minus 8x minus 3y all over 6y squared plus 3x. That is the final answer. You see that? So implicit function is also straightforward. So I expect you to solve a lot of questions I'm going to give you, and then you get back to me. Thank you very much.